Hi, this is a presentation of the paper entitled Assessing the Impact of OCR Errors in Information Retrieval. This work was done by Guilherme Basso, Gustavo Lorenz, Dani Vargas, and Viviane Moreira. We are from the Institute of Informatics at URGS in Brazil. We'll start by giving you the context of our research. It's widely accepted that most of the information useful for organizations is represented in an unstructured format, predominantly as free text. A significant portion of this text is stored in PDF files. PDF documents need to be converted into plain text before being processed. If a PDF file was created from a scanned document, it contains an image of the original document and needs to go through OCR so that its textual contents can be extracted. Our motivation is that the output of OCR may have errors, and these errors can have a negative impact on the quality of IR systems. These problems affect even mainstream search engines. This figure shows a snippet generated by Google Scholar for the query information retrieval techniques and its corresponding PDF source. We can see that even in this small snippet, there are 4 errors. In 3 cases, a word was erroneously separated into 2, and in 1 case, 2 words were joined into 1. The negative effect here is that the query with a correct spelling of these words would not be able to retrieve this document. Our goal is to revisit the problem of retrieving OCR text and quantify the impact that potential errors have on the quality of IR systems. Ideally, to do that, we would need an IR test collection with source PDF files, their extracted and corrected versions, a set of queries, and their corresponding relevance judgments. Unfortunately, this collection does not exist. So instead, we use a systematic error insertion procedure on a standard IR test collection. The main differences between this work and existing works are: we assess the use of stemming, more recent ranking algorithms, and more levels of degradation. Also, our experiments were done in a text collection in Portuguese, which is a language that has been largely overlooked in IR experimentation. Here's an overview of our error insertion process. First, we take a sample of aligned text containing extracted and expected pairs of words. This sample was assembled from 900 PDF documents, which were extracted with ABFIND Reader 14 and then manually checked for correction. From these aligned pairs, we build a character exchange list, which looks a bit like this excerpt in blue. We have the original character, the character has been swapped for, and the frequency in which this change happens. The frequency is important because we want to simulate errors as they happen in reality. Error insertion takes 3 more inputs: the original clean documents, which come from the Folha de São Paulo test collection, which is a Brazilian newspaper, the error rate, which specifies the desired level of degradation, and candidate selection, which is a configuration that informs which set of terms can have errors inserted. In our setting, they were either taken from the entire set of documents or just from the judged documents. We then iterate through every candidate term in the document and decide whether it should be modified with a probability equivalent to the given error rate. In the end, our output has documents with artificially inserted errors. Here's a summary of our experimental runs. We tested 3 ranking algorithms: the cosine, the M25, and the FR. We tried using stemming and not using stemming. Error rates varied from 1 to 50%, and we also have a baseline run in which no error was inserted. Our candidate terms were taken from either all the documents or just the judged documents. All these variations amounted to a total of 72 experimental runs, which were evaluated using standard IR metrics. Statistical significance was measured using t-tests. This table shows mean average precision results for our different settings. The shaded cells indicate a statistically significant decrease in relation to the baseline. Significant differences start on 5% error rates. At a 10% error rate, all runs are significantly affected. According to recent studies, the error rate found in OCR of historical documents is around 20%, which means a significant degradation in our tests. The use of stemming consistently improved the results. All runs in which stemming was used had higher scores than their unstemmed counterparts. The aid of stemming is more noticeable in the runs with higher error rates. The benefits can be explained by the fact that OCR error can be in the suffix that ends up being removed by the stemmer. DFR was the best ranking function, followed by BM25. However, there were no differences on their robustness in the presence of OCR errors, as their pattern of map decrease was just about the same. Conclusion. Despite having been investigated for decades, the issues associated with retrieving noisy text still remain unsolved in many IR systems. In this work, we revisited this topic by assessing the impact that different error rates have on retrieval performance. We tested different setups, including ranking algorithms and the use of stemming. Our findings suggest that statistically significant degradation starts at a word error rate of 5%, and that stemming is able to make systems more resilient to these errors. As future work, it would be useful to assess which type of error has the greatest impact in retrieval quality. Thanks for watching. Please send us feedback and questions to the email on the screen. This work was supported by Petrobras, CNPq Brazil, and CAPES.